Yeah, it's late, officially late now. So let's use, I probably haven't left enough space for each of those. There's a lot of writing for the alternating series test. How many mini tests are there in the alternating series test? No, just two. What's the first test? To show that the function's decreasing and also to show that it's the nth term, the absolute value of the nth term is approaching 0. And if you do, then you know it's converging, isn't it? So let's just do this, shall we? So first of all, we've got an alternating series there. Okay, let's just test to see if it converges. So we've got to show, so first of all I have to show, just to remind us, for an alternating series test we've got to show that UK plus 1 is always less than UK. Yep. Good. So how will I do this, do you think? I'll go K plus 1 to the power of 2 on 3 is K plus 1 to the power of 2 is greater than K to the power of 2 on 3. Yeah? Therefore 1 on K plus 1 to the power of 2/3 will be less than 1 on K to the 2/3. Therefore, this is a decrease there. Yeah? Therefore, the absolute value of UK is decreasing. Good. Next test.
How do you know the 2/3 of the K plus 1 to the power of 2/3? That's small. It's greater than.
Well, it is. That's just logic, isn't it? Remember, K is greater than 1. Remember, K is greater than 1, isn't it? K is an integer greater than. I'm not sure what that is in the question, but I think that might be 2 and infinity. So K is an integer. K is an integer greater than that. What's the other way to do it, Vincent? You could just differentiate and show it's always going to be negative, which it always will be. Yeah. Okay. So what's my second test? What's the second test? Just got to find the limit as K approaches infinity. Yeah. Of 1 divided by K to the power of 2/3, and guess what that limit equals to? 0. Yeah? So that limit there is equal to 0. Good. So therefore, what's my conclusion? Therefore, this alternating series is convergent. Yeah. So let's just conclude that.
U 就是那个数列里面的一项，我们原来写数列不是用 U 来表示。
Therefore, the alternating series is convergent. Let's do this one, shall we? Yeah. Yeah, I just got some questions from 5, and just thought. So I just got 3 questions. Let's just practice using the alternating series test. Next one. How do we do this one? So let's go here. 1. Part 1 again. I've just got to show. Ooh, how will I show that one? Well, I've got to show that UK plus 1 is going to be less than UK. Do you know what? I don't think I need to show that. I think I can just jump straight to the second test. Can't I? Well, I'll show you. Look, I might just leave that. In fact, I'm just going to jump straight and say, find the limit. I can see what's going to happen here. What's the limit as k approaches to infinity of 2k plus 3 on 3k plus 4? That's going to equal to, ready, the limit as k approaches infinity of 2 plus 3 on k divided by 3 plus 4 on k, which equals to 2 plus 0 divided by 3 plus 0, which equals to 2/3. Therefore it's divergent. At infinity, you're just going plus or minus 2/3. It's never going to converge to a fixed value. Okay? It's going to just oscillate backwards and forwards, but never approach a fixed value at infinity. So therefore, we say here, therefore converges. Because this value diverges, sorry. Gosh, thank you, Diana. How about this one? Aha! What does this bit here do, everyone? What does that bit there do? That's just my sine generator, isn't it? That's just generating the alternating series. So that's how I recognise, if this was a test, that that's an alternating series. Yeah? This is just going to be my sine generator. Yay. So let's apply the first test. What's the first test? So I've got to show that UK plus 1 is less than UK. So how will I do this? I reckon I'll just go ln k plus 1 is greater than ln k. That implies 1 divided by ln k plus 1 is less than 1 on ln k. Therefore, it's decreasing.
Is it always necessary to do part 1? That shows UK plus 1.
Well, in this case I didn't. I just did part 2 first because I could see straight away I was going to fail part 2. So you just got to show it. It looks like it's going to fail. Yeah. No, there's no order. You can do part 2 first and then part 1. There's no order of operation here.
But do we must do part 1? Do we must do both of them in our
No. No. Well, yes, to show it's convergent. No, not for divergence. In other words, I only need to show that it fails one of the tests. If it fails one of the tests, then it's divergent. To show it's convergent, it's got to pass both tests. So let's go to the second test. What's my second test? Basically that, I've got to show that the limit as k approaches infinity of 1 on ln k, and what's that limit equal to? 0. Therefore, this alternating series here is convergent. Now, is there a way? These are very, very hard. This is convergent. This is convergent, ladies and gentlemen. But convergent to what? Convergent to what value? And how would you work that out? Well, guess what? For some of these, it's almost impossible. But what we can do is we can give an approximate value for how accurate that is. Yeah, we can give an approximate value to a certain degree of error. So I want to find out how far I could be away from a particular sum, and what's what's a guess in terms of that error? What is the error in how far I am away? Now, the more terms I use, the closer I'm going to get to my sum. Agreed? Yeah? And I'll get closer and closer and closer within a certain degree of error. So the next part of those questions, do you just want to have a look? I'm on page 90. I'm on page... Sorry, I don't have my glasses. I'll just grab that. Yeah, I'm on page 85. Are we on page 85? Can we just read question 5? Because I've only done part 1 of this question. We haven't done the theory to part 2, but let's do that now. It says, use the alternating series test to determine whether the following series converges or not. You're on the wrong page, Arthur. I'm on page 85. I'm looking at question 5. And it says here, use the alternating series test to determine whether the following series are convergent or not. And that's just what I've done. So there's 3 examples there. I'll set a few for homework and you can work out whether they're convergent or not, right? But the second part of the question says, where they do converge, find the upper bound to 3 significant figures on the error in taking the first 10 terms of the series as an approximation. So, to find out what this converges to, what I could do is add up the first 10 terms. In adding up the first 10 terms, how far am I away from the true value? Do you understand what that question is? So in other words, hey, let's just take this one here. How far am I away from the first, by adding up the first 10 terms? So this is what this question is saying. It's saying the first term, this starts at 2, right? So what's my first term? 1 divided by ln 2. What's my second term? Minus 1 divided by ln 3. What's my third term? 1 divided by ln, that's my third term. What's my 10th term? What's my 10th term? That's going to be 1 divided by ln 11. Positive or negative? Plus, isn't it? These are even negative. Thank you. Yes. Now, of course, there's more terms here, aren't they? Yeah. So if I keep going plus ... guess what that equals to? That equals to my sum. Yeah. In other words, this here is equal to some sum. Do I know what my sum is? No. Right. Okay. Do I know what S is? No. Do I know what S10 is? Yeah. What's S10? That is S10. How far is S10 away from S? What would I need to have to add in here? I would need, in physics or whatever, you might call this the, I call this the error term. In other words, ladies and gentlemen, if I add my error term to S10, what should I get? Theoretically, Arthur, if I knew what my error term was, what I could do is this, ready? I could go S10 plus error term equals to S. Very good. Do I know what my error term is? Why not, Vincent? Why don't I know what my error term is? Could you ever find your error term exactly? If you could find your error term exactly, you just add it to S10 and you know what the sum is. Do I know what the sum of these series are sometimes? No. You can't work out the sum of these. But if you knew your error term exactly, guess what? You would. Because you just add the error term to S5, S6 or whatever and you'd get the actual sum. Does that make sense? So, do you ever know your error term? No. Can I get an estimate of the error term, or what we call the upper bound? Could I get a value that was close to the error term, but a term that was just a little bit bigger than what the error term is? Because you never know your error term. If you know how much your error is, then you know the answer. And your error term's not an error term. Kind of makes sense. It's a bit weird, isn't it? If you knew how big that was, then you could find S every single time. Therefore, you don't know what the error term is. However, what we can do is we can give very quickly what we call an upper bound, or a good guess to what that error is, an upper bound. I want us to now create an upper bound for the error term. So our job now is to create an upper bound for the error term in an alternating series. That's my job. In an alternating series, I need to find an upper bound. What does an upper bound mean? An upper bound means the error term, but it's going to be bigger than what the true. If there's a true error term, I don't know what it is, but what I know is I can find an error term that's a little bit bigger than the true value, and I'll show you how we do that, right? So let me just draw a picture of that for you over here. On this axis here is n, on this axis here is Sn. Yeah? Let's just say I know, well I don't know, let's just say this is my S. That's my S. What does that mean? That's the sum to infinity. Let's just say I know what S infinity is, and that's it. Okay? Let's just look at my first guess. Yep, so what does U1 take me to? Let's just pretend U1 takes me up to here. Whee, we go up to there. This is U1, yeah? What's this called? S what? S1. Good. Now, if it's an alternating series, U2 will take you above S or below S infinity. Yeah, so let's add on, so we'll just leave it up there. Let's add on the next one, U2, down here. U2 is negative, isn't it? It's a positive term, if you like, plus negative, isn't it? Okay, good. So, what's this called? What's this? This is my sum 2. Very good. Hey, does anyone notice something? Watch this. Where's U3? U3 is going to be up here. Correct, everyone? About there. So, what's this? What's this one here called? S3. Now, when I'm at S2, how far am I away from S infinity? When I'm at S2, how far away am I from S infinity? Look at this. There's S2 there, and that's how far I'm away. So that's the error. That's the error in taking the sum to. That's the error. That's the difference between S2 and S infinity, and we call this the error in using the second term. Do you know what I mean? The error in summing up the first two terms. So if I went to a third term, would the error be less? So if you like, what's this one? This is really S infinity, isn't it? Minus S2, and we'll take the absolute value because error is always positive. Agreed? Now, what do we call this? Can someone tell me what would we call this? Please have a go. What would that be called? Error term in what? Yeah, that's the error term in approximating the sum using two terms. Agreed? What's this going to be then? What's this one here going to be, please? What would that distance from there to there be? That would be, what's this? This would be S infinity minus S3 absolute value. What would that be? That would be the error in approximating the sum to using the sum of three terms. Agreed? Now, watch this. Is everyone ready? Okay, this is the trick. This error, that error, is less than U3. Do you agree? Is everyone watching? Everyone watching? Ready? Let me write this down. You ready? Asterisk. S infinity minus S2, that error there is less than that value. True or false? True. Good. Do you agree with that? Yeah? Okay. Yes? That distance there is less than that. So, can someone tell me what this is going to be? What should I write here? S infinity minus S3 is going to be less than U4. Correct, there's U4 there. That distance is less than U4. Therefore, S infinity, which is just called S, minus Sn is going to be less than Un plus 1. Thank you. How do I say that? Arthur? How do I say that in English? The error in approximating the sum to n terms will be less than the value of the nth plus 1 term. Wow. Let me write that down. Let's go, Vincent. Let's write that down. Here we go. The error in approximating S using Sn in using the sum, I'll write this out, using this sum of n terms, yeah, is less than the value, I should put the absolute value there, isn't it? It's all absolute stuff, is less than the absolute value of the n plus 1 term. Cool? Is it an upper bound? Yeah, it's an upper bound because that is bigger, this is bigger than that. So that's why this is called an upper bound. It's an upper bound, yeah? So again, you might like to just put a little dot around again and just write, this is an upper bound. And I think in your key point in your textbook, which is really quite good, the key point in the textbooks, really quite good. That's what I think they call it, the upper bound. Okay, let me just read out what's on page 78 for you. I hope that's playing for, yeah, it is recording. Page 78, let me just read this to you. Key point 3.8. Actually, I think everyone's writing stuff down. I'll just wait. I think you really need to take that down. A lot of students struggle with that. I'll give you 5 minutes. Yeah? rub that off in a moment. Oh, actually, yeah, look, I'll rub some of it off in a moment. But take your time and do it. It's really good to draw it, isn't it? Makes sense when you actually draw it, don't yeah? So how did you go with the Shenzhen? Yeah, no. So, Arthur, in the textbook it asks us to find the error in using the first 10 terms for any series that converges. Of course, divergent ones, this doesn't work for, does it? It only works for convergent. So, I've done 2 up on the board, Vincent, that are convergent. This one is convergent. So we're going to find the error. How far are we away from the true value as an upper bound using the first 10 terms of this one? Yeah? And how far are we away from the true value using the first 10 terms of that one? That's our job. Yeah? Now, if your series is alternating, very quickly you can get an upper bound for the error. In the next chapter, we use a very, very complex way to get that error term. Really hard. Wait till you see it. This is a much easier way. We can produce an error term for certain series that are not alternating. Yeah? But however, alternating series, this is the quickest way and the best way to do it. Believe it or not, I've never seen any question on this at all. Even though it's in the syllabus, for some reason this is kind of seems a little bit too tricky, but let's do it nonetheless. Okay, let's analyse this one. So I'm going to rub that off, and I'm just going to rub off this little bit here, okay? Because that's where I'm going to do the working for the second part of the question. The second part of the question to this was find the error term. So again, let's go back to our page 85, question 5. It says, where they do converge, find the upper bound to 3 significant figures. Find the error in taking the first 10 terms of the series as an approximation. Right, and what will I do my solutions in? Blue. Blue is a good colour, so let's do the solution in blue. Let's rub this off because this one diverges. So of course that's not going to work, and let's just rub this bit off here. Hopefully we've got that down. We're going to create the upper bound now. Let's find the upper bound for the error. Right, first 10 terms. So, gosh, I hope we can do this. Anyway, we don't need to know what S10 is, do we? No, we only need to find what U... In other words, the error in using the first 10 terms is S minus S10. That's the error in using the first 10 terms to approximate S. How far we're out. Of course, what's that less than? That's less than U11. So I need to find what U11 is. How do I find what U11 is? How do I find what U11 is? Well, that's easy, isn't it? Just got to go U11 is equal to 1 divided by 11 to the power of 2/3. Someone got a calculator to work that out for me? That's how easy it is. I'll show you where it gets a little bit tricky in a sec. Vincent, make sense? I'm going to ask you an extension on this question in a sec, right now. So everyone pay attention. I'm finding out what the 11th is because that's the error. What do I get? 0.02. 2. Good. That's the 3 significant figures, right? That's a fair way out, isn't it? That's 0.2 out from what the real answer was if I was to sum up the first 10 terms. I'm not happy with that. I'm not happy at all with that. That's not very accurate. How many terms do I need so that it's accurate to 0.001? That's the more than likely the question you're going to be asked. Do you understand what I'm saying? 10 terms summing up 10 terms gets me 0.2 away from what S is. I don't want to be 0.2 away from S. I want to be 0.001. How many terms do I need? Well, I don't know, we've got to guess. So what question is it I'm asking is this: how many terms do we need such that S minus S n, we've got to find what n is, don't we? Yeah, is going to be less than 0.001. How do I do that? Well, what I can do here is I know that this is going to be equal to u n plus 1. Agreed? So what have I got to find? N. So that's right. So I've got 1 divided by n plus 1 to the power of 2/3 has got to equal to 0.001. So let's reciprocate that. So I get n plus 1 to the power of 2/3 is going to equal to 1,000. Turn everything upside down. Turn both sides upside down. Yeah? How do I get this by itself? I need to raise that to the power of 2/3 or 1.5, wouldn't I? So I get n plus 1 equals 1,000 to the power of 3 on 2. No. 3 on 2.
It's 2 on 3. This is 2 on 3.
Yeah, but I need to raise it to 3 on 2. If I raise this to 3 on 2, I get 1. And I've got to raise that to 3 on 2. Yeah, agree? And then subtract 1. Can someone do that for me? So in other words, I need n equals to 1,000 to the 3 on 2 minus 1. How many terms do I need? Can someone work that out? Susan, quick. Or Arthur. I don't care which.
Oh, 31,600.
31,000 terms. Really? Wow. Okay. 31, was it 31,000? 621 point what? 0.8. So how many terms do I need? Should I round up or round down? Yeah, I'm going to need the next term. Yeah? I'm going to need the next term to make it less than. So my answer would be equals to 31,622. Can you now please repeat what I've done, but for this question? I'm not going to do it, I'm going to watch you do it. You can't leave until you do that right now. I want you to do this same thing. Exactly that. I want you to find the error in using the 10th, which you can check in your book. And then I want you to do that. Go. Practice. It's good for you. Just checking time. Sorry. Coronavirus. Yeah? Do you understand? So there's two questions there. Yeah? The first one's over here is I want you to find the error in using the first 10 terms. That's part 1. And part 2, I want you to do that for over here. You need to do it, do it. Yeah.
You also want it to be the accuracy to be
Yeah, within 0.001. How many terms do I need? So the answer to the first one's relatively straightforward, isn't it?
0.
That's just U11 is going to equal to 1 divided by ln 11, whatever that number is. What is that number, by the way? What's 1 divided by ln 11?
0.417.
0. Point.
417.
12.
Oh,
Yeah, 12.
yeah. No, 13.
12.
12, yeah. 12. Agreed. What's that equal to, sorry? Very good. Thank you. Good.
0.4.
Point.
402.
And how about this? How many terms did I need? How many terms did I need for 1 divided by ln to the n plus 1 equal to 0.001? What did n need to be? Huge number, is it?
Okay, times 10 to the power 433.
Ah, you're kidding. No way. Wow. Whew. Yeah, that's massive. Okay, yeah. This is the answer. We need this many terms. So not a very good question by Mr. Stewart there.
所以就是 n 加
Wow, that's a lot of terms. Plus 1 probably. Plus an extra 1. But yeah, that's a lot of terms. Yeah, and that's not even, yeah, that's not accurate because I have to. Is that what you're getting?
Yeah.
Is that one point n plus 1 equals to e
Did you put the minus
Yes.
1 to the power?
是我
你们是不是都一人读解
E to the power of 1,000
Yeah,
minus 1.
Yeah, did you
Yes.
put the minus 1 to the
1.9.
power?
1.97 times 10. Oh my god.
I told you.
So, yeah. Let's just write n is very big.
It's still a huge number. Plus.
Yeah, not a good question. Not a good question. Bad question. You know, I didn't know what that value would be. Yeah, so you need a lot of terms to get accuracy, don't you? Okay. And this is really hard because we can't really use the integral test either as an upper bound, you know, because we could confine it either side using an integral test, couldn't we? Could confine it from the integral of that, but the problem with the integral test is the integral test doesn't take into account positives and negatives. The integral test just takes into account positive terms, so there's no other way to get the answer to this other than to do this. Right, let's move on. Yeah? Okay, let's keep going. And tomorrow we can do a big summary on this if we get everything done. Okay, can I rub this off, please?
Mrs. Stewart.
Yes, ma'am. Pardon? Oh, okay. Is everyone happy if I rub that off? Good. Yes, sir. That's the sort.
Yeah.
So what's the next one? Oh wait, the 44 answer.
好的
The end of term.
还有哦，考3分
from
Yeah. Are you okay? Hey everyone, if it makes you feel better, we're getting close to the end of this chapter, and then there's one chapter to go this semester after this. If that makes you feel better, I hope it does. And then it's a long break until we'll do maths again. Yeah, and you can do your option paper. You can actually do and start practicing for your option exams. Okay, so that's I hope that kind of invigorates you. It invigorates me because, yeah, I need invigorating as well. I'm here doing the teaching when I could be like many others, just not doing anything. But yeah, let's keep that in the back of our mind, and we'll use that as encouragement to get this done. Yeah. So the next thing I need to talk to you about is conditional and absolute convergence. And I think you'll find this really interesting. Conditional and absolute convergence. And you know what? I think this might be the last thing I do today. I'm not sure whether going on to the ratio test is a good idea. I think we're pretty exhausted. What's the time? Is it 3 o'clock? Yeah, I don't think we're going to get... We'll probably have to do a double period tomorrow. We'll just see, or a single.
Double period.
I know. We're not quite going to get everything done this week, I don't think. I'm sorry. Conditional and absolute convergence. That's the heading. This is kind of the next test. So let's just run through the tests in our head, shall we? Test 1, divergence test. Test 2, comparison test. Test 3, limit comparison test. Test 4, integral test. Test 5, alternating series test. Test 5A. No, test 5A is error in using the error term. Yeah, just put that in the back of our mind. We've got that error term associated with an alternating series. Yeah. Test 6 is what I'm going to call absolute convergence test. Now, what is the difference between conditional convergence and absolute convergence? Let me show you here. Please consider this. If we have this sum, the sum from minus 1k plus 1 on k. Ladies and gentlemen, is that series convergent or divergent? This is, yeah, we just did this, before, didn't we? This series is convergent. Why? Because it passes the alternating series test, doesn't it? Yeah. So this is an alternating series, and it passes the alternating series test. This is 1 minus a half plus a third minus a quarter plus ... This series we know is convergent. It passes the alternating series test. However, if I take the absolute value of that, what do I find? In other words, if I was to do this, I'm going to take the absolute value of this. Let's take the absolute value of that. What does it equal to? That equals to... Which equals to 1. What do we know about that series, everyone? Convergent or divergent? Convergent or divergent? Divergent, why? Because it fails the P test. Yeah? Does anyone know what the name of that series is? Do you remember? It has a special name. It's called the harmonic series. Yeah? So this is divergent. It's called the harmonic series. Has a special name, that series. It converges to ln2, I think. 0.693. Yeah, it converges to ln2. That's called the harmonic series. Now, any series that is convergent, but when you take the absolute value of it, it becomes divergent, is called conditionally convergent. Does that make sense? So if a series is normally convergent, but if I take the absolute value of that series and I find the absolute value of that series is divergent, then this series is called conditionally convergent. So this series here, what's this series called? This is called, well, we can add another term, it's called conditionally convergent. Why is it conditionally convergent? Because when we take the absolute value of the series, we find the absolute value is divergent. Do you want me to write that down? Good. So let me do this in blue then. This series here is conditionally convergent. This series is conditionally convergent. Because if we take the absolute sum of the series, we find that the series is divergent. So when the absolute value is divergent, but the original series is convergent, then we have a special name. What do we call this? We call this conditionally convergent.
So Mr. Sure, this one is different to the one that you said.
Let me show you what absolutely convergent is. What's absolutely convergent then, do you think? When the alternating series is convergent and when the absolute value of the series is convergent. We call this absolutely convergent. Therefore, if a series is absolutely convergent, what does that mean? If any series is absolutely convergent, then it's convergent. Yeah? Is the absolute value of this series convergent? No, therefore it's called conditionally convergent. But here, let's just do an example. Are you ready? I'll do this one. The sum minus 1 k plus 1 from 1 to infinity of 1 on k squared. Convergent or divergent? Convergent or divergent? Well, that one's going to pass the alternating series test for sure, isn't it? Again, if we did a double check, yeah, what's the nth term going to be? 0. Yeah, the infinitive term is going to be 0, and also it's a decreasing function. So we would expect this to be convergent. Very good. So this one here is clearly, in other words, this is 1 minus 1 on 2 squared plus 1 on 3 squared minus 1 on 4 squared. Yeah, this here is convergent. That's convergent. Guess what? If we take the absolute value of that, let's take the absolute value. Here's the absolute value of that. What does that equal to? The absolute value means I don't have to worry about the positive and the negative. I take the absolute value of that, I get ready 1 plus a half, 1 plus 2 squared plus 1 on 3 squared plus 1 on 4 squared. Is this convergent or divergent? That's convergent also, isn't it? Because we know because of the p-test. Yeah? That one there plus ... is equal to the sum of 1 on k squared. which we know is convergent because of the p-test. Convergent because p-test. My point here is this. If it's absolutely convergent, then what must be true? It must be convergent. Because taking the absolute value, if we find the absolute value is convergent, then of course the alternating must be convergent also. Why? Because it's going, positive, negative, positive, negative. Do you agree with that? So, if absolutely it's convergent, then it's convergent. So if we test for absolute convergence, sometimes that's easier to do, and we find it's absolutely convergent, then the original series, if it's alternating, must clearly be convergent as well. Because absolute's taking a bigger value, isn't it? Absolute's making sure every term is positive, which is going to give you a bigger number. If that bigger number is convergent, then the smaller number must be convergent as well. If you've got negatives in there, and you're making everything positive, and you add up all the positives and you find that's convergent, then the alternating one must be convergent as well. Agreed? I should write that down and I will. Yeah?
422.
Therefore, let's do this. Are you ready? In fact, I'll write that down. Therefore, basically this. Yeah? Any series.
因为 P test 解释的这个我当时不在那节课，你在，你要用那个 integral test 去反推吧，原理是 P test。那反推过程我怎么不可能用话给你讲出来了？我给你翻书上哪有？看它的次方的呀。
第一次方就是。
对呀。反正就是它小于等于一次方的时候，就是大于一次方是考虑。你不是让我给你解释原理吗？
解释就有。
Agreed? Any series that is absolutely convergent, if we take the absolute value and we find it's convergent, then it must be convergent as well. So let's look at a really, really tricky series. Yeah? Let's look at the one in the example in the textbook is really good. Let's consider this one. Are you ready? So we've got the sum from 1 to infinity of sine of k divided by k squared. Is that convergent or is that divergent? Now I think it's convergent straight away. But let's look at the alternating series value. Who's got a calculator in radians at the moment? What I want us to do is find the first few terms. The first term is sine of 1 divided by 1 squared. And then we've got sine of 2 divided by 2 squared. Plus we got sine of 3 divided by 3 squared. Yeah? Plus sine of 4 divided by 4 squared. Let's just leave it there. Can someone tell me what those numbers add up to? You've got them. Do you just want to read them out? We've got
0.841.
0.841. What's the next one? Plus or negative? Plus?
0.227.
Well, sine of 2 is a positive number, isn't it? Is sine of 3 positive? Yeah, it's still above pi. However, this one, sine of 4 is negative. Anyway, let's go. So what's this one? 0.227. Next one? 0.0156. And what's the next one? Minus 0.047. And I think the next one will be minus as well. So, sometimes these terms are positive, sometimes they're negative. Is that series convergent or divergent? How do I know? Because it's not a purely alternating series. So I can't use the alternating series test. Some terms are positive and some terms are negative, but it's not alternating. What does alternating mean? It means positive, negative, positive, negative, positive, negative, positive, negative. This is not going like that. This is going positive, 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 negative, 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 positive, positive, negative. Do you know what I mean? We don't know. So this is not an alternating. So we can't use the alternating series test. How do we know, therefore, that it's convergent? What do we have to use? The absolute convergence test. Let's just make that function absolute, and if it's absolutely convergent, then I know it's convergent. So, what I'm going to do here, ladies and gentlemen, is I'm going to take this, and I'm just going to say, well, let's do what's called an absolute convergence test. So I'm going to do can't spell here, absolute convergence test. Okay, let's find that this series absolutely converges. Ready? So what do I need to do? I take this series and I go absolute value of sine k divided by k squared. Why don't I take the absolute value of k squared? Don't need to, it's positive. Yeah? So now what am I going to do? I'm going to use a comparison test here. Because what I'm going to say is sine k, the absolute value of sine k is always less than 1. Yeah, always less than 1 or equal to 1. In fact, don't think it'll ever equal to 1. It'll always be less than, because you'll never end up with a ratio of pi. Yeah, if that's a integer, you'll never get pi or pi on 2. So it's always less than 1 in this case. So sine k is less than 1. So therefore, what's this series less than? That's less than 1 on k squared. And why does this converge? This converges because of the, we've got converging p-test. Great. And why does this one converge? Why does that one converge? Because of the comparison test. So we've got proof of convergence via comparison test.
Mr. Shaw,
Yeah.
could you say again why absolute value of sine k is always less than 1?
Yes.
Why?
Well, how can sine ever be 1 or negative 1? It must be pi on 2. What's pi? Pi is irrational. 1, 2, 3, 4, 5 will always be integer values. Yeah? Pi is irrational, so you'll never get pi on 2. No matter how many, no matter where you go. Yeah? Agree? So does everyone understand that logic? This is convergent. Yeah? Therefore that's convergent. If this is absolutely convergent, what does that say about this? It's convergent as well. Therefore, yeah? Proof of, I should have put this, this is proof of convergence, it's proof of absolute convergence. I haven't finished yet. Via the comparison test. Therefore, what's my conclusion? Therefore, this is convergent via the absolute convergence test. Yeah? Therefore, wow, Nathan, quite a lot of conclusions there, isn't it? Yeah? This series here is convergent because of the p-test. Therefore, this series is convergent, yeah, via the comparison test. Therefore, this series is convergent via the absolute convergence test. Wow. Tricky stuff, isn't it? Hey, so why do I care? And this is the bit you're going to find really interesting. Why do I care about conditional convergence then? What's so special? Why would you have a special name for conditional convergence? And this is the reason. I think you're going to really enjoy this. In a conditional convergence situation, you can organise the terms to create a mathematical contradiction. Let me do it for you. Yeah? Can I rub off? Can I rub off this bit here? Can I rub off this? Yeah. Do you need time? Do you need time?
因为 K 是那个
It's fine. I'm going to finish off in 5 minutes. What's the time?
20 past.
Yeah, I have to anyway, or otherwise the video will be an hour long and it won't upload. So quickly, I better do this. Are you ready? In fact, I think it's been going for over an hour now, hasn't it? So I'm sorry, I hope this loads. It may not. Are we ready? Can I show you something really interesting? Let's take a... Quickly, I've got to move on. Let's take a conditionally convergent series. Are you ready? Let's go. 1 minus a half plus 1/3 minus a quarter plus 1/5 minus 1/6. Is that right? Yeah? Plus 1/7 minus 1/8 plus 1/9 minus 1/10 plus 1/11, blah, 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 blah. Agreed? Guess what that's equal to? That's equal to S. What sort of series is that? It's a alternating series. We also know that particular series is a conditionally convergent series. Agreed? Watch this. S, okay, S equals to this. S equals to 1 minus a half. Cool. Plus, minus a quarter. Minus a quarter. So I've used that. Plus 1/3 minus 1/6. Minus 1/8 plus 1/5 minus 1/10. Yeah? Plus, minus 1/12 plus 1/7 minus 1/14 plus blah blah blah. Do you see, everyone? I'm using all of the terms here to create a new series. Agreed? They're still equal, isn't it? If I use all of the terms in this series and I rearrange it like this, I'm using all the same terms. Agreed? I'm just reordering them in a special way. Agreed? They're still equal, aren't they? I can just keep going all the way to infinity, and I can go all the way to infinity, and I'll use the same terms. So let's just quickly have a look at this. S equals 2. What's 1 minus a half? A half. What's a half minus a quarter? What's this? 1/3 minus a 1/6 is plus a 1/6. Minus an 1/8. Yeah? Plus a 1/10. Minus a 12th. Plus a 14th. Cool? Let's take a half out from that series. So I'm going to take a half out. A half, 1 minus a half, plus a 1/3, minus a quarter, plus a 1/5, minus ... Agreed? What's this equal to? S. So S equals to a half S. You can only do this. You can only create a mathematical contradiction with conditionally convergent series. Interesting, isn't it? Yeah. That's why really maths is cool in a lot of ways, isn't it? So, what's my point here? You can only do this, ladies and gentlemen. You can only rearrange conditionally convergent series. Any conditionally convergent series can create a contradiction like this. And that's what makes them conditionally convergent. Isn't that interesting? Why? Well, I don't really know. That's probably something you need to ask someone who's better than me or more of a mathematician anyway, who knows more about it. But let me just say that's if you have a conditionally convergent series, you can rearrange it to form a mathematical contradiction. To show your parents that one if you like. You cannot disprove that. I'll see you later on that note. See you tomorrow. Yeah, unfortunately we're not going to quite get everything done, but we're going to get so close. I've never taught chapter 3 in 1 week. We're getting very, very close to do it. We've done doubles almost every day. See you later on.